Welcome. In this video I'm going to show you how you can perform a one sample Wilcoxon signed rank test using Python and my stikpetP library. I'm using Python version 3.8.18 and this test can be used to test a hypothesized median. Alternatives would be the one sample sign test or one sample trinomial test. This video will focus simply on getting the output. To show you how it can be done, I'll first need some example data. So I load in pandas just so I can use their read CSV function. And then I can load in the general social survey data from 2012 adjusted. I actually don't need all this data. I only need one ordinal field. I'm going to be using account sci, which is short for account scientific, which shows the responses on how scientific accounting is. I'll store those under ord field, and just to give you a quick impression, I use the values count, so you can see that, for example, 199 people thought it was pretty scientific. I'll actually put these options in a separate dictionary, ranging in the proper order, and assign each of them a numeric value. My library is available from my GitHub account, so please use pip install and then a full link to my GitHub account, and then you can import it just as any other library. The function of interest is ts, test, Wilcoxon one sample. It has a few parameters to choose from. The data, of course, that we'll need. If that's non-numerical, you can specify the levels, that's that coding. The hypothesized median to use, if you don't specify it, the mid-range will be used, which is the maximum plus the minimum, and then divided by 2. You can opt to use a ties correction. You can opt to either use the exact distribution, or if your sample size is very large, you probably want to use a normal approximation, which is done by using Wilcoxon, because that will give you the approximation that Wilcoxon came up with. Iman actually also came up with a normal approximation, and also one using a student t distribution. The equal met is about if scores are tied with the hypothesized median. You can either just remove them, that's what Wilcoxon does, or you can actually adjust the test statistic according to either the pret method or the z-split method. If you're using an approximation, you can also set the continuity correction either to true or false. So it's fairly straightforward. We have the function, we feed it the data and the coding, and it returns a few things. The number of ranks used in the calculation, the hypothesized median used, the sum of the ranks of the positive differences, the statistic, that's the z value, or if you're using the t distribution, the t value. Degrees of freedom, only applicable with a student t approximation. The p-value, in this case, very close to 0, and a small description of the test that was used. In this case, it's below 0.05, so that would indicate that we would reject the null hypothesis, and therefore the median is significantly different from 2.5. It can also use an exact test, provided there are no ties. So for example, I have a small list here, and there are no ties, so it's done actually an exact test, and it then has just a p-value of 0.69. So in this case, we would not reject the null hypothesis. So that median could still be 8.1. There's insufficient evidence to claim something else. Alright, I hope this video was helpful, and thank you for watching.